So in order to answer this question, it's easy to look at this work here that I've written instead of typing. So we look at the beginning here, we see that at midnight t is equal to 0. 070 must be the first data point in the set. The highest temperature is 85, the lowest is 55. That gives us our mins and maxes on the graph. And we want to use a sine wave since we're starting at what we consider like the midline here, because it's going to start at 70 and it's going to end at 70 as well. We really don't know exactly when the max and mins occur, but for a sine wave, usually you have a max a quarter of the way through the cycle, and then the min is about 3/4 of the way, assuming you have a positive amplitude to start. So given that graph and given that information, and given our standard form of a sine wave here, we could fill in for these different spots. The amplitude is 15 because it's the distance from the midline to the max. That's this 15 here. The frequency is 2 pi divided by the period being 24 hours. So it's 2 pi over 24. This graph has not shifted horizontally. We know that because the starting point for a sine wave is always going to be here. If it were to start over here, then we consider it a sine wave that was shifted over. And then finally, the vertical shift, or the midline, is 70. So that's going to be your last portion over here at the end. So it's always going to be your amplitude here in the front. Then you're going to have your frequency times t, which is your independent variable, plus the midline of 70 there.